Good day, students. Welcome to mathgoodserve.com. In this clip, we're going to be going over problems 1 to 5 of the Algebra 2 New York Regents for January 2015. All right, let's take a look at problem number 1. So for problem 1, it reads, in triangle FGH, lowercase f is equal to 6, lowercase g is equal to 9, um, the measure of angle H is 57 degrees. Which statement can be used to determine the numerical value of lowercase h? And then we have the setups here with the values substituted. Now, if you consult your reference sheet, you will find one of the three variations of the law of cosines. Let's go ahead and write it down. The law of cosines is one of them is a square equals b square plus c square minus 2bc cosine uppercase a. All right. Anytime you're using the law of cosines, if you're looking for a side length, you always want to start with that side length. That's how you determine the right formula to use. All right. So we have three sides here in an angle: lowercase a, lowercase b, lowercase c, and an angle a. And then in this problem, we have three lower cases, f, g, and h, and then an angle h. So how do we rewrite this formula using these letters that are provided here? Okay, so in order to do that, first thing we're going to do, let's go ahead and list what we know on this formula. From this formula, we have lowercase a, lowercase b, and lowercase c, and then uppercase a. All right. Now, since a square is what comes first, it's going to be equivalent to h. Why is that? Well, it is because that is what you're looking for. Okay, always start with the lowercase letter that you're looking for. So little a is equal to lowercase h, and that is what we're looking for, question mark. All right, always start with that. B and C are equivalent to F and G. The order doesn't matter here. Okay, you know multiplication commutes. BC or CB and addition commutes also. C squared plus B squared, B squared plus C squared. You will get the same answer. It doesn't really matter. So I'm going to call lowercase b the same as F, which is equal to 6. Lowercase c is equivalent to G, which is equal to 9. And then uppercase A is equivalent to big H. Okay? You can see the connection here. Lowercase a is lowercase h. Uppercase A is uppercase h. Alright? And that is 57 degrees. Now before we substitute the values, let's rewrite the formula using the letters in this triangle FGH. So a squared will be equivalent to h squared. A is h. B squared is going to be f squared. B is f. And then c squared is g squared minus 2bc, 2fg cosine a. A is big H. Okay? Now that we have our formula written using the applicable letters, FGH, now we can substitute the value to set up the statements that can be used to determine the value of h. Okay, so now for h, what do we substitute in for h? We do not know what h is, so it remains as a variable. H squared equals f squared is 6 squared plus g is 9 plus 9 squared minus 2f is 6, g is 9, cosine 57. There goes your statement that you can use to find the value of h. Okay, so let's see what letter corresponds to what we have here. Let's see, h squared. This has 9 and h, that's no good. H squared, good, good, good. 2, 6, 9, bam. Our answer is option number 2. All right, let's take a look at problem 2. It says, the table of values below can be modeled by which equation? So we have two functions of x here and two functions of y. If you look at this function of x, option number one, absolute value of x plus 3, this represents a shift in the left direction. So this is 3 units to the left. That's what this means. Absolute value of x plus 3, this is a shift 3 units upwards. Okay, in that direction. Now here, this is going to be a function of y. Okay, so you have y plus 3. It's going to be a function of y, but since we're going in the y direction, this would be equivalent to shifting down 3 units. And then this right here plus 3 is going to be equivalent to shifting to the right 3 units. Okay? Now you want to note that for option 1 and 2, these are absolute values that are functions of x. So this would be like a v that's shifted to the left. This will be a v that's shifted upwards. All right? And this, since it's a function of y, the v is going to be in this orientation, is going to be rotated uh, clockwise, is going to be like this. So you're going to have a v facing this direction shifted down. And then this one you have a v in this direction shifted to the right. Okay? Now, let's see. If you take a look at this graph right here, if you examine the y's, you notice that the y's are decreasing and then they start to increase. This is a function of x. Okay? This is the dependent. This is the independent. So since this is a function of x, we can automatically eliminate 3 and 4. All right? Now, let's go ahead and take a look at this. Now, if you notice, it goes from 4 to 3 and then to 4. So we have a corner somewhere here. So if we graph just these 3 points, these 3 pairs of points right here, that should be sufficient for us to determine exactly what the answer is. Is it option 1 or 2? Are we shifting to the left or are we shifting upwards? All right, so I'm just going to graph 3 points and that should be more than enough. Okay, it's centered around x equals 0, so I can put my y-axis in the center. The lowest y value is 3. Uh-oh. The lowest y value is 3, so I can just put my x-axis down here. That should suffice. And I'll just graph these 3 ordered pairs, and that should be enough for me to determine which option is correct. Okay, so let's see. 0, 3. Let's graph that. 0, 3. When x is 0, y is 3. There. And then negative 1, 4. This is negative 1, 4. So this is 3, 4. And then 1. 1 goes to 4. So you see what's happening with the absolute value function? Let's go ahead and draw the entire thing. So there you go. Follow that pattern forever. And then here, follow that pattern forever. So what happened to the parent absolute value function? The parent absolute value function sits right here. Okay, that's the original one. Sits right here. So what do you do to the original absolute value function to get this translated function? You shift it 3 units upwards. Okay, so this right here is f of x equals absolute value of x. When you shift it 3 units up, you end up with f of x equals the absolute value of x plus 3. Okay, so our answer is option number 2. Another way you can do this is you take a look at the vertex. Okay, the vertex is 0, comma 3. So this is h, and this is k. And you know that for absolute values, you can write it as f of x equals the absolute value of x plus h. I'm sorry, f of x minus h, it's not plus. F of x minus h plus k. If you plug in the values of h and k that you got from the vertex, the coordinates of the vertex, you're going to have f of x equals absolute value of x minus 0 plus 3. And then when you simplify it, you have what we got earlier. absolute value of x plus 3. Answer is option number 2. Alright, let's take a look at problem number 3. It says the equation log base a of x equals y, where x is greater than 0 and a greater than 1, is equivalent to, so we have log base a of x equals y. So all we just have to do here is isolate x. Okay, so how do you isolate x? We're going to make use of a property of logarithm, inverse property. So a to the log base a of y. Do you know what this is? Exponents and logarithms are inverse properties, so this is going to be y because these two cancel out. All right. So to take advantage of this property of logarithms, I'm going to look at the base here. The base is a. That will be the basis of my exponentiation. Okay, so I'll exponentiate both sides. The left side I put a big A here. The right side I put a big A. On the left side I'll have a little log base A of x equals, on the right side I'll have a little a. Okay, now on the left side what happens is that the a and log base A are inverses, so they cancel each other out. So you have on the left side x is equal to a to the y. So one thing you do not want to forget is always exponentiate both sides, not just one side, so you don't make a mistake. Now using the reflexive property of equality, I can rewrite this as a to the y, just switch it around, equals x. And we can clearly see that our final answer is option number 3. Alright, let's take a look at problem number 4. It says which expression is equivalent to the sum of the sequence 6, 12, 20, and 30. Alright, so we have 4 options here. Now, all we just have to do, the safest and most effective way to determine the right answer is to make table of values and generate outputs. Whichever option generates these exact 4 outputs, that is your correct answer. Alright, so let's go ahead and start with option number 1. So option number 1, let's set up our table. Well, let's write down the problem first. So that's the sum, the discrete sum from n equals 4 to 7 of 2 to the n minus 10. So what we'll do is we'll set up a table of values and start to generate our outputs. Okay, so put a line right there, one right here. So we're going to have the independent variables n, and then our outputs are going to be generated by substituting the values of n into 2 to the n minus 10. Okay? Alright, so we're going from 4 to 7, so we'll start with 4. What do we do with 4? We plug 4 into n here. So we're going to have 2 to the 4th power minus 10. 2 to the 4th power is 4 times 4 is 16. 16 minus 10, which is equal to 6. Is that the first option that we have here? The answer is yes, so that's good. What do we do next? Well, we're going from 4 to 7. So the next number after 4 is 5. So we plug in 5. When we plug in 5, what are we looking for? The question we're going to be having in mind is that, does my answer match the second number in this sequence, 12? Okay, so let's keep that in mind. So we have 2 to the 5th minus 10. 2 to the 5th power is 32. 32 minus 10 is what? 22. Do we have a match? No, that's wrong. Okay, that doesn't match 12. So what does that mean? Option 1 is not the answer. So we advance to option 2. Option 2, we're looking at a discrete sum from n equals 3 to 6. And then we're going to carry out the same process. substituting the values of n into 2n squared over 3, generating a table of values to see if our outputs match this sequence right here. Okay, let's go ahead and do it. All right, so we have n, and we have n, and the function that we are going to be using to generate our outputs are 2n squared over 3. Okay? All right, so let's start with the first input. What is our first input? 3. We're going from 3 all the way to 6, right? So let's plug in 3 and see what our output is. So we have 2 times 3 squared over 3. All right, using the order of operations, we have 2, 3 squared is 9 over 3. 18 over 3 is 6. Is that good? Yes, it is, because the first number in the sequence is 6. Now we're going to advance to generating the next term in the sequence. Um, what do we input to generate that output? We're going to have to go to with the number after 3, right? Because we're going from 3 to 6. The next integer after 3 is 4, so we're going to plug in 4 into this function. 2 times 4 square over 3. The goal is to get 12, okay? Let's see what happens here. So we have 4 squared is 16. 16 times 2 is, uh, 16 times 2 is 32. 32 over 3, that's not even an integer. It's 10 and 2/3. That clearly is not 12. We want 12. That's the second number, right? So what does that tell us? It tells us that this output is wrong and option 2 is not the correct answer. Okay, let's move on to the next one, option 3. Option 3, we have the sum from n equals 2 to 5. We're going to be plugging in n from 2 to 5 into 5n minus 4. Let's set up our table so we can stay organized and keep track of our work. Have a table there. Independent variables n will start from 2 and go all the way to 5. We're going to be plugging in our n values into 5n minus 4. Now, just by inspection, it's easy to tell that this is wrong. How is that? Option 3, this sequence is arithmetic. You have a constant difference, a common difference of 5. But if you look at this sequence right here, you have a common difference. From here to here is 6, right? If you add 6 to 12, do you get 20? The answer is no. So based on that fact, we can automatically conclude that this is not the answer. Because this is not an arithmetic sequence, okay? Now, let's assume that we didn't make that observation and we're just blindly generating outputs. So, in this case, we're going to go from 2 all the way to 5 and see if our outputs match these sequence values, which clearly will not. All right, let's just try it out. So, plugging 2 into this function here, 5 times 2 minus 4. Using all of operations, 10 minus 4, 6, looking good. Now, based on what I said earlier, the common difference is 5, so we should expect the output here to just simply be 5 more, which is 11, okay? So let's test out that hypothesis, see if it is actually true. So you plug in the next number, which is 3. So you're going to have 5 times 3 minus 4. 15 minus 4 is what? 11. See, the common difference there is 5. But is that what we have here? The answer is no. Okay? So by method of elimination, we can automatically conclude that our answer is option number 4. Okay? But just to satisfy our curiosity, let's go ahead and make a table of values and see if option 4 in fact generates the outputs of this sequence. All right, so for option 4, we're going to be plugging in n into the sequence n square, into the function n square plus n. Let's start with 2. Plug 2 here. 2 squared plus 2. 2 squared is 4 plus 2 is 6. That checks out. The next one is 3. Plug 3 in there. 3 squared plus 3. 3 squared is 9. 9 plus 3 is 12. That checks out also because that matches the second number in the sequence. So continue. Next one is 4, 2, 3, 4, 5. Okay, so 4 squared plus 4. 4 squared is 16 plus 4. That's 20. That's good. It matches the third number in the sequence. Last but not the least is 5. And we just plug in 5 into this function right here. So we have 5 and 5 squared plus 5. 5 squared is 25 plus 5. That's 30. And that is also a match. So we can see that our answer is option number 4. All right, let's take a look at the last one, problem 5. It says an investment is earning 5% interest compounded quarterly. The equation A equals P times 1 plus R over N raised to the NT represents the total amount of money A, where P is the original investment, R is the interest rate, T is the number of years, and N represents the number of times per year the money earns interest. Which graph could represent this investment over at least 50 years? So we have, let's see, we have 4 options here. Which of these graphs represents an exponential function? That's what the problem is asking. If you remember what an exponential function looks like, you can clearly see that option 1 is the answer. Okay, option 2 is a logarithmic function. This is a linear function, and this could be a polynomial function of degree 3 because you have 2 terms here. But just for confirmation, how about we just refresh our memory by generating the graph of some random exponential function. Okay, so let's say we have 2 times 1. Oh, let's take a look at the standard. So the variable is going to be, we have the n. Okay, so let's bring that back up. So 1 plus 3. Let's say the rate is 0.2, right? 0.2 over 5 raised to the 5x. Okay, so this is an example of an exponential function. Let's put the power in parentheses so we do not have a grouping error here. So parentheses 5x. So what we're looking at is just how does the graph look like? That's all we care about. How does the graph look like? And I'm going to do a standard zoom in a second. Let's finish graphing first. So zoom standard, zoom 6. You see, that is what an exponential function looks like, right? But since we do not have negative time, we just eliminate this portion. All we focus in on is the positive portion of the graph, okay? So if we look at the positive portion of the graph, which of these options here looks like this? Clearly option number 1. So we can clearly see that this is the correct answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. We'd like to know what you all think about this clip. So if you like it, go ahead and give us a thumbs up. If we get at least 20 thumbs up on this video, then we'll go ahead and make the remaining parts of this series. And don't forget to subscribe after giving us a review so that you can get immediate notification about the subsequent upgrade. Okay, so go ahead and let us know what you think about this video. More clips can be found on mathcodeserve.com under test prep. Thanks again for watching and have a wonderful day.